Two great warm-up problems for you. Yeah. That's where I get my water. Yeah, everybody was absent. Domain, first one. Go for it. X cannot equal what? 3?
No. 0.
So what does that mean for a vertical asymptote? X equals 0. Horizontal asymptote? None. Agree with that? Okay. Love it. Second one. Domain. Do we agree with
Plus or minus the square root of 6?
all real numbers except x cannot equal 6, or plus or minus the square root of 6? Seems to be some dissension. Plus, I don't like either one of them. Okay, we know it starts all real numbers, right? Right?
Plus or minus I square root of 6, right?
Hmm?
And then B plus or minus R.
Okay, so what do I do? Step number 1 tells me what? What do I have to do? Set what? Denominator equals 0. So that's x squared plus 6 equals 0. Right? First, x squared equals negative 6. X equals plus or minus I times the square root of 6. Right? That's my domain.
X plus or minus I square root of 6.
That's my domain. Go with it. Why is it just all real numbers? Because those are imaginary. They're not real. They're not real. So they be gone. Okay? So what does that mean vertical asymptote-wise? There is none. Horizontal asymptote. So x equals 2? Yeah. Agree with x equals 2 for a horizontal asymptote. No. Why not? I like y equals 2 better because it's horizontal. Questions? Okay. Find me all the asymptotes for all three of them, their functions. First one, what's its asymptotes?
Vertical asymptote is all real numbers.
That's a lot of vertical asymptotes.
X equals 2.
What? So there's no asymptotes whatsoever? Okay. And what? Do we agree with y equals 0 for the horizontal asymptote? Is that the only one? Second one. What do you got?
Horizontal asymptote of 2/3.
That's a number.
Y equals 2/3.
Y equals 2/3? That's an asymptote. Any other ones? Any other ones for that one? Okay. Third one? None? None whatsoever? Okay. Questions on any of those three? So, extra sheet now. We're on a reference sheet. We're just going to put these right on a reference sheet. Okay? Step number 3 says, I need to find the y-intercept. how do I go about finding the y-intercept?
Wherever the line goes through the y-axis.
Okay? Wherever the line crosses the y-axis, or wherever our function crosses the y-axis.
Do you make x equal 0?
And then do what?
Solve.
In the original function? Okay? So basically what you're saying is I'm going to find f of 0.
Yeah.
Right? Okay? So make x be 0, plug in 0, however you say it, gets me out a number. Okay? Love it. Step number 4. What do you think we're going to find in step number 4? X-intercept. What's the x-intercept? Well, we don't have y in our function. How do I find the x-intercept?
Can you change to a 1?
Change what to a y?
F.
Okay.
Just replace it with 1.
So what are we doing then, basically?
Making it.
I can change my function notation back into y, right? And then I make my y equal to 0. What am I basically doing? Setting my function equal to 0. So the x-intercept is where my function is equal to 0. Okay? Deep Thoughts by Linzmeyer. What form is my function? What do all of these functions look like? Every function we've had so far has always looked like something. It's what? A fraction. Okay? So how can I find the 0 of a fraction? Or when a fraction is equal to 0? Intermediate's got this stuff written all over the place. So I got a fraction equal to 0. When is that fraction equal to 0? A over B. Only happens in one case. What? So if I had 4 divided by 4, what's that equal to? 1. That's not 0. What? Okay, so which one? Can you divide by 0? Is your name Chuck Norris? So can you divide by 0? No. Okay? So this fraction is only equal to 0 if what? If a is 0. Right? So in a rational function, how do I find the x-intercept, which is where my function is equal to 0? So what? Set the numerator equal to 0. So I set the numerator equal to 0, and I find those spots. Now, my question to you is this. How many y-intercepts can my function have? How many y-intercepts can my function have?
One.
Only one? What do you mean? Because if it had 2, it wouldn't be a function, right? Or more, it wouldn't be a function. Okay? So it can have 1. That's the only possibility. Could have none or 1, right? Okay? So y-intercepts, I can only have 0 or 1. Right? Okay? How many x-intercepts can we have? How many can we have? Say it. We can have as many as we want, right? How do I know how many we have? Of what? Of what? Of what? Of what? The numerator. The degree of the numerator, because that tells me how many zeros I got to get, right? And each 0 is a x-intercept. Okay? So the degree of the numerator tells me how many zeros I'm going to have. Okay? Love it. Now, both the y-intercept and the x-intercept are what? X-intercept and y-intercepts are what? Points. What form do points come in? Parentheses and a comma, right? Would all of the y-intercepts look very similar? Would all of the x-intercepts look very similar? What would they all look like? This one would be what? 0, comma, some number, right? And this one would be?
Some number.
Comma 0, right? Right? Okay. Now, we're going to have a step number 5. And we're going to have a step number 6. But we're not there yet. Okay? So skip down to the bottom of your page, or if you're already at the lower 2/3 of your page, go to the back side, whatever you need to do. Okay? Because we have the last step that we have is step number 7. Step number 7 says we're going to find other points using a T-chart. And you're actually going to use multiple T-charts. And I'll show you what that means when we get into graphing these functions on the next slide. Okay? But your last step, step number 7, says we're going to find other points using T-charts. Okay? All right, let's get into one. So now we're on the pink graph paper. I love this graph paper for many reasons. Okay, 1, pink is my favorite color. Okay, 2, you got plenty of space to show all of your work to go along with the actual picture so that they're not disenchanted and one's in one area and one's in the other area. Everything's all right there. Okay? So first off, I would start by writing down what the function is, or the f of x equals, in this case, 2x over x plus 1. Put that function either up above the graph or off to the side or somewhere, but you want to have that with you so that you know what we're talking about. Okay? Cheat sheet, reference guide, tells me step number 1 is what?
From the side of the denominator equals.
So I first find the domain and the vertical asymptote, right? Okay, what is the domain? What are the vertical asymptotes?
Domain is all real numbers except for when x, or x cannot equal -1. And the vertical asymptote is x equals -1.
Agreed. Okay. Step number 2 says what? Find the horizontal asymptote. Degree of the top, 1. Degree of the bottom, 1. They're the same, right? So that was option number C, right? Okay. Which is what? A over B, right?
Take the leading coefficient.
Okay. What do you got, Stoner?
Y equals 2.
Y equals 2. Okay. Step number 3 says what? Find the y-intercept. How am I going to find the y-intercept?
Find the f of 0.
Find f of 0. So I'm going to plug in 0 into my function. Two times 0, 0 plus 1, 0 divided by 1, 0. So my y-intercept is 0, 0. Step number 4 says what? Find the x-intercept. How am I going to find the x-intercept? So I set the numerator, in this case the numerator is 2x. I set that equal to 0. Solve that, x equals 0. So my x-intercept is 0, 0. That shouldn't come as a surprise to you, because if one of them is the origin, the other one is the origin. It's the only point where it's both. Okay? Just a little bit. Okay? Now, tap the brakes. Back into, I want that one. There we go. Okay? Now, let's put some stuff on there. How does my vertical asymptote go onto the graph? Line, so it's straight. Vertical, it's up and down. -1. And it's dashed. Dashed. Good try. How does my horizontal asymptote go on my graph? It's a line, it's horizontal, it's straight, at 2, and it's dashed. How does my y-intercept go on the graph? do I put there? A dot. How does my x-intercept go on the graph? The dot. It's the same dot, right? Okay. So I'll make it be two-colored. With me? Okay. Love it. Love everything about it so far. But now we've come to the end of our steps, right? So now we would normally go to step 5. We don't have step 5 yet. We'll get that next week. Then we go to step 6. We don't have that yet. We'll get that later next week. Then let's go to step 7. Step 7 says I'm going to have to make a t-chart to find other values that my function goes through. Now, I will tell you this. I will preface this by saying that my function cannot look like that. Why not? Vertical line test would fail in that case, and these are functions. So, I can only be in one section here. This is a section, and this is a section. Okay? So those are my two zones, if you will. Okay? So I'm going to make a t-chart for each zone. Now, over on this side, I've already got a point in that zone, so I'm going to try 1 then. If I put 1 into my function, 2 times 1 is 2. 1 plus 1 is 2. 2 divided by 2 is 1. So I'm going to go through the point 1, comma 1. Then I'm going to do something farther away, like 10. 2 times 10 is 20. 10 plus 1 is 11. 20 divided by 11 is like 1.9. Then I go to this side. Negative 2. If I put negative 2 in there, I get negative 4 over negative 1. That's equal to positive 4. Negative 3. Negative 6 over negative 2. That's going to be 3. Negative 10. That's going to be negative 20 over negative 9. That's going to be negative 2.2. Oh, positive. Good call. Now I've got enough to draw in my function. Right? Now, it also said, give me the asymptotal and the end behaviors, right? Super easy to do now. Here we go. Ready for them? As x goes to negative infinity, because that's what's happening over here, right? Right over here. What's my function going to go to? What's my function going to go to? Get closer and closer and closer to. $93. I can throw out random numbers too. 2. 2 from above, right? You said it below? Where's the... It's on the top side of the red line, right? Or the red dash line? Yeah, so it's going to go to 2 from above. as x goes to -1 from the left, my function goes to positive infinity. As x goes to positive infinity, my function goes to 2 from below. We have to scroll down on this one. As x goes to -1 from the right, my function goes to negative infinity. You had to learn logic the last 2 days so that you can check your work and you know that you got it right. Okay. Questions? Go for it. Agree so far? Okay, put stuff on the graph. Yes? How many zones do we have? 3. So that means I've got 3 T-charts to make. Okay. So let's first do this zone over here. So that's going to be -3. If I put -3 in there on top, I get -18. On the bottom, I get 5. negative 18 divided by positive 5 is negative 3.6. Okay. 3.6. If I put negative 10 in there, I get negative 200 on the top divided by 96, which is going to be a little bit more than negative 2, right? Negative 2 point what?
0.8.
0.8.
Yeah.
Okay, so that's going to be right up there tight, right? That tells me that that's going to curve through down in that lower half. Yes? Okay, love it. Then I'm going to try negative 1. Put negative 1 into that function, and that's going to give me negative 2 over negative 3, which is going to be 2/3. Then I'm going to put positive 1 in there. That's going to give me negative 2 over negative 3, which is going to be positive 2/3. That to me says, okay, I'm going to have a parabola up there. Because this was a double here in purple, this was a double root, that means a kiss. Okay? Okay? So I'm going to kiss the x-axis at 0. So that's going to be going back up. Okay? Then I've got over here, let's go with positive 3. If I put positive 3 on the top, I get negative 18. If I put positive 3 on the bottom, I get negative 5. That gets me right down there. And if I put positive 10 in there, I get negative 200 over 96. That's me right there. So we can graph, or we can draw it in, I should say. That is going to allow me to do my asymptotal behavior and end behavior here. I'll go down here and write it. So as x approaches negative infinity, my function is going to approach negative 2 from below. As x approaches positive infinity, my function is going to approach negative 2 from below. As x approaches negative 2 from the left, my function approaches negative infinity. As x approaches negative 2 from the right, my function, that one's going up, that's that middle section. And then as x approaches 2 from the left, my function also is going up. And as x approaches 2 from the left, or excuse me, from the right, f of x is going down. Okay? Tomorrow is what? Quiz day. Okay? There will be a graphing problem on tomorrow's quiz. I strongly recommend that you practice at least a graphing problem tonight. This is homework packet number 1. This homework packet will be due next week, Wednesday.